Hi, I'm David. Engine management systems have come a long way in a very short period of time. The heart of the engine management system is the Engine Control Module, or ECM. This video is part of a series dedicated to petrol engine management. The ECM receives signals about the engine parameters from the sensors and sends out controls to activate various components. The sensors are covered in another video in this series. The controls can include fuel injectors, ignition coils, throttle body, canister purge, cooling fan operation, variable manifold control, malfunction indicator lamp, fuel pump control, starter relay, powertrain relay, oxygen sensor heaters, and possibly generator control. This video will examine how the ECM looks after fuel delivery. The schematics and sample waveforms used are typical of most vehicles. Always refer to the correct information applicable to your particular vehicle. In early systems, the injectors were controlled simultaneously or in groups by having B+ to the injector and the module supplying the ground via a low-side driver. In simultaneous operation, the injectors are opened all together. Half of the calculated fuel required is delivered each revolution of the crankshaft. The advantage to this system is that it only uses one output stage, thereby reducing the electronics in the module. This is also a disadvantage. If the output stage fails, then no fuel can be injected. Grouped injection still supplies half the amount of fuel needed each crankshaft revolution, but there are now several output stages. On a 6-cylinder, there could be 2 groups of 3 injectors or 3 groups of 2 injectors. A 4-cylinder will have 2 groups of 2 injectors. The modules are now more complex, but if an output stage fails, not all the injectors are affected. With the ever-increasing demand for lower emissions and better fuel economy came sequential injection. The injectors now open in the engine's firing order, usually just before the intake valve opens. This improved low-speed operation. There was no real advantage at higher engine speeds, so most engine management systems revert to grouped injection under these operating conditions. The quantity of fuel delivered by the injectors can be controlled in 2 ways: by either the time the injector is opened, injection duration, or the pressure in the fuel rail. The easiest way is via injection duration. The longer the injector is open means more fuel will enter the system. Here is a typical injection pattern, showing the duration changing with the engine speed. There is a drawback to this method. To get the best atomization of the fuel, we need high pressure. If there was high pressure in the fuel rail all the time, then the injector opening times at idle would be very small. These small injector durations would be hard to control. Controlling the fuel pressure as well as the duration solves this problem. A lower pressure is used at lower speeds and a higher pressure is used at higher speeds. This ensures the best atomization and control at all times. Here is the injection pattern for one of these engines. If the engine speed is increased slowly, it can be seen that the injection duration doesn't change very much, as the amount of extra fuel is being provided by the increase in fuel pressure. If I snap open the accelerator, it can be seen that this time the injection duration increased. This happened because the fuel pressure cannot rise quickly enough to provide the extra fuel. This is a turbocharged engine, so the extra fuel required under boost conditions can be provided by a fuel pressure increase as well as extended injection duration. Reducing the resistance of the injector will allow it to open quicker, but the control of the injector needs to be different. Instead of simply grounding the injector for a given period of time, the control now needs to be pulse width modulated. This will prevent the injector coil from overheating. Here is the injection pattern from a direct injected engine. This system uses high voltage from a capacitor discharge circuit to open the injector. The voltage is pulse width modulated to hold the injector open. If the engine speed is increased slowly, it can be seen that the injection duration doesn't change very much, as the amount of extra fuel is being provided by the increase in fuel pressure. This time, if I snap open the accelerator, it can be seen that the injection duration of the high voltage didn't change, but there were extra pulses added to extend the injector on time. This happened because the fuel pressure cannot rise quickly enough to provide the extra fuel. With these types of injectors comes a change in the control circuit. Now both sides of the injector are switched. So you can see there are many variations in the control of injectors. There are different ways the ECM can control a fuel pump. This can be by a relay, an integrated fuel pump module in the ECM, or an external fuel pump module. In a relay-operated pump, the relay receives a control from a driver within the ECM. This will energise the relay, closing the switch contacts, allowing the current to flow to the pump. Systems that use a fuel pump control module are generally used where control of the fuel pressure is required. The ECM sends a fuel pump enable and a calculated desired fuel pressure to the fuel pump control module. The module now operates the pump to achieve the desired fuel pressure. This is done via a PWM control to the fuel pump. The pump speed is changed by varying the duty cycle of this control. A fuel pressure sensor provides fuel pressure feedback to the fuel pump control module. The ECM will operate the fuel pump under the following conditions. First, the system needs to be primed. This is done at ignition on. The ECM will operate the fuel pump for a given period of time, then if it doesn't see an engine crank signal or engine run signal, then the pump will be turned off. As soon as the ECM receives an engine crank or run signal, the pump will be turned on again. If the engine is turned off or the engine run signal is lost, then the fuel pump will be turned off. This is a safety feature to prevent fuel from being discharged in the event of a broken fuel line. That's how the ECM controls the fuel delivery for the injectors and the fuel pump. Becoming familiar with the operation of different systems will help you pinpoint any faults. And remember, training is knowledge. Knowledge to keep you ahead of the game. Bye for now.